This is a video on acid-metal reactions for the topic Chemical World for Year 9 Science. The beauty of these types of reactions is that it's pretty much more or less the same idea as neutralization reactions in another video I made in terms of naming the salt that's formed. So acid-metal reactions are pretty straightforward. It's basically when you have an acid and you mix it with a metal, and that gives you a salt and hydrogen gas. Okay, it's not salt and water, it's hydrogen gas. Okay, so when you throw in a metal into a test tube, it's a very simple experiment. Throw in a piece of, I don't know, sodium into some acid, you'll see bubbles, and those bubbles formed are indicative of the presence of hydrogen gas. And you'll see like a white powder or different colored powder building up at the bottom, depositing typically. That's the salt that's formed. Okay, you can actually extract the salt by evaporating the solution. But anyway, it's very simple. So the acid is typically aqueous. Aqueous means it's in a solution. It's a liquid. Metal, the metal is a solid. Typically takes the form of a solid. The salt that's formed is solid. And the hydrogen gas, as the name suggests, is a gas. So let's do some examples to see how this works. I'm going to use 4 common acid names that typically pops up in exams. These are classic examples. Let's do some examples to see how this works. So example 1, suppose I have hydrochloric acid reacting with sodium metal, and I need to work out what the products are. So step 1, as always, it's a step-by-step process. It's a recipe. Step 1 is to write down the products. Products formed in this case, if you look up there at the general equation, is a salt and hydrogen. So the salt, write down salt and hydrogen gas for now. Step 2 is to identify the salt. Let's get the salt. Now, salt by definition, just as is the case in neutralization reactions, is an ionic compound. In other words, it consists of a metal stuck together with a non-metal atom. Now, all you have to do is eyeball the equation and identify where the metal is. So the metal in this case is sodium. So write down sodium first. That goes, when you're naming an ionic compound, you write down the name of the metal first, which is sodium. The non-metal comes from the acid, and the ending here, chloric, becomes chloride, IDE. And that's it. That's the name of the salt, and this is table salt. So you can actually make table salt in the lab just by mixing hydrochloric acid and sodium metal. So that's the rule with chloric, it becomes chloride. Okay, that's the first type of acid, common acid. And whatever metal you use, could be sodium, calcium, francium, you'll get francium, say francium chloride. If it's calcium metal, you get calcium chloride, and so on and so forth. Example 1, let's do another example. Example 2. Suppose I have magnesium and nitric acid. Okay, once again, let's write down the products. Write down products. So the first step is to write down salt and hydrogen gas, or just hydrogen works as well. Step 2 is to identify the salt. Once again, and I encourage you to write this down in an exam, because under pressure in an exam you can forget things quite easily. Doesn't matter how smart you are. Exam pressure always gets everyone. So write down metal plus non-metal so you don't forget. So you don't have a mind blank as well. Okay, eyeballing this expression, be very careful. Sometimes they can swap the acid and metal positions. The metal is magnesium. Okay. I got asked today in class, sir, how do I know what the metal is? Just look at your periodic table. And using your basic knowledge and understanding of the periodic table of where the metals are and where the non-metals are. So magnesium is a metal, it's in group 2. So you write down magnesium. And the non-metal comes from the acid. In this case, the nitric becomes nitrate, ATE. Okay, that's the rule. When working with nitric acid, you write down nitrate. So that's the salt. That's acid number 2. Okay, once again, if you have, let's say, gold plus nitric acid, it becomes gold nitrate for the salt, and so on and so forth. Example 3, so up to the third common acid, sulfuric acid plus calcium. And let's work this out. So step 1 is to write the products. So salt and hydrogen gas. Step 2 is to identify the salt. Remember, it's metal and non-metal. Now, eyeballing this expression, calcium is the metal. It's in group 2 as well, like magnesium. So you write down calcium. The non-metal comes from the acid. The sulfuric becomes sulfate. So I'm hoping you're seeing a common trend here now. If it ends in IC, it becomes 8, right? Calcium sulfate. Let's do another example. Example 4, the final example, I should say. Suppose you have acetic acid plus rubidium. Okay, going through the steps once again. Number 1 is to identify, I should say, write the products. So salt plus hydrogen gas. Step 2, identify the salt. Okay, salt is metal and non-metal. Metal in the equation here is rubidium. It's a group 1 element. So rubidium, non-metal comes from the acid. Acetic becomes acetate. Okay, so the 4 common acids, to summarize, hydrochloric, sulfuric, nitric, and acetic. This becomes ide, chloride. This becomes 8, sulfate. This becomes nitrate. This becomes acetate. Okay, so you've got 3 8s and 1 ide, typically. And that's pretty much acid-metal reactions.